Alright, let's talk more about some exponents. This video is going to be called Exponent 2 Notes. Alright, and it deals with some more laws on exponents. So let's go straight to it and look at it. Here's what the note sheet looks like. Let's get a little closer so we can talk some stuff. Exponents 2 Notes. This one talks about the product of powers. Alright, product means multiply. And then powers is dealing with expressions with exponents. Alright, so we're going to be multiplying expressions with exponents. So the law says that if you have a product of powers, alright, you're multiplying exponents. And this only works when you have powers with the same base. And if you have that situation, you add the exponents. An example, a to the m power times a to the n power. You agree that these two expressions both have an a raised to some exponent, whether it's m or n. Well, if you have that situation, the law says that you can really write this as a to the m plus n. Alright? Now I know that sometimes these expressions can be a little confusing. Let's do a real life problem. Question number 1. A to the 5th power times a to the 3rd power. Well, the law says that if you have these two expressions with the same base, we have two a's and they're both being raised to an exponent. You can really say this like a to the 5 plus 3 power. Well, 5 plus 3 is some easy mathematics. 5 plus 3 is just 8. So this expression right here is really just a to the 8th power. And that's your answer. That's the whole idea behind these laws. It helps us to make an easier situation to work with. These two expressions separate is a little bit more complicated than just that expression simplified. Alright? So let's keep on working. Number 2. Alright, I have all these parentheses. Well, parentheses means multiply. So I have this product of powers rule. The one thing that I did not talk to you about is this guy right here. You see the negative sign in front of that a? That negative sign is a coefficient. Alright, it's really like -1 times a squared. Well, coefficients are not under the power of these exponents. Alright, when we're talking about these laws. These laws are only for exponents and things like that. Right now, that negative sign is not under any power. Alright, only this a is. Okay, so what we're going to do is we're going to kind of like say that this negative sign, alright, this -1 right here, is going to be separate from everything. So we're going to lead off with that. That's a -1. Then I have a to the 7th times a to the 2 times a to the... Does this guy have an exponent? Well, it's not there, but it's really like an imaginary 1. Alright? So it's kind of like saying that I have these three expressions that all have the same base, the same letter, raised to an exponent. So it's kind of like saying that we have a to the 7 plus 2 plus 1. I'm just adding all these exponents. Well, when you do that, you're going to end up with a -1a. Could I just write -a? I could, right? I don't have to write that 1. And if I wanted to add all these exponents up, 7 plus 2 is 9, plus 1 more is 10. And that's my solution. So this expression right here definitely looks a lot more simple to work with than those. Alright, let's keep going. Question number 3. I've got 4a squared times a to the 0 power. Now wait a second. This a to the 0 power looks like our lesson before, our previous lesson. What's anything raised to the 0 power? It's 1. It can be canceled out. So really this is like 4a squared times 1, which is really just 4a squared. Alright, so a little bit of review of what happened last time. Now, what if I didn't remember this special rule? Could I still do this work? Absolutely. I have 4a. If I have a squared times a to the 0, it's kind of like a 2 plus 0. And sure enough, 2 plus 0 does equal out to just give me 4a squared. Okay? So whether you go this route by remembering the a to the 0 power, or if you do the product of powers rule, you're going to get the same answers. But this is a whole lot more simple if you remember those special rules we talked about yesterday, or in the video before. Question number 4. That looks like a whole bunch of stuff. I notice in here that I've got some coefficients, and I've got some powers with different bases. Like I've got an m, and then I've got an m. Alright? I'm just giving those underlines to let you know that they're different. Alright? Now remember, your coefficients have no laws of exponents because they don't have exponents. They're just numbers. So if you just have 8 and a negative 3 as your coefficients, and they're inside some parentheses, that just means you're multiplying. So we're going to take 8 times negative 3. We'll do that in a minute. What I want to do right now is I just want to put everything that's alike together. Alright? So, I put my coefficients together. Let's go ahead and write out what these mean. Let's write out what the m to the 5th power and m to the 3rd power means. If we agree that all these that are in here is all straight up multiplication, I know that by the multiply sign, then it's really like saying m to the 5th times m to the 3rd. Well, that's product of power rule. That's really just m to the 5 plus 3. Same thing with the n. I have n to the negative 4 times n to the, that's an imaginary 1. Alright, now I know some of you are saying, hey coach, wait a second, that's a bad kid, that's a negative exponent, we can put him in the basement. Don't do that until you have completed all of your laws of exponents. Alright, your product rule, and then there's some more rules that we're going to talk about. Let's go ahead and do our product rule first. So if I have these two expressions that have the same base, it's really like saying n to the negative 4 plus 1. Now, let's do all this multiplying. This times that gives me a negative 24. M to the 5 plus 3 is m to the 8. And then n to the negative 4 plus 1, that's like n to the negative 3. Now you can say, hey coach, that's a negative exponent. That's a bad kid. He needs to go down to the bottom of the basement, or the bottom of your fraction. Now you can take care of that rule. Alright, all you got to do is move him down there. Negative 24 is not an exponent. He cannot be moved. He stays up at the top. He's a coefficient. There's no rule that tells him to go to the basement. M to the 8th is a good kid. He stays where he is. N to the negative 3 is a bad kid. Put him down there, and then he becomes a good kid. That's your answer. You know it's your answer because I have no 0 exponents, and I have no negative exponents. One more problem. Look at all these coefficients. Put them all together. 10 times negative 3.
Attention students and teachers.
Alright, times negative 2. There's all your coefficients. Let's look at all of our powers with x as the base. So I have x to the 3 and then x to the negative 7. So that's really x to the 3 plus negative 7. Alright, we'll deal with that when we get there. Then I want to look at powers with y. Alright, now look at this one. That is 0. That's a 0 exponent. We can go ahead and cancel him out right now. Go ahead and do it right now. You don't have to wait till the end. Alrighty? So the only one that has a y with an exponent is this guy. So just put him down there. Now that I've got everybody together, let's go ahead and do our products. Let's do a multiply. 10 times a negative 3 times a negative 2. Well, 10 times negative 3 is negative 30. Times negative 2 is a positive 60. Then x to the 3 plus a negative 7 is really x to the negative 4. And then y to the 4th is just y to the 4th. There's no product with him. Alright, but I do notice that I've got a bad kid. Negative exponent. He needs to go down to the basement. Alright, so this expression is really going to be 60. He's a coefficient, stays where he is on the fraction. This bad kid needs to go down to the bottom, so x to the 4th Remember, when you put them down to the basement, you change it to a positive exponent. That's how you change those negative exponents. And then y to the fourth stays where it is. That's your solution. That's your simplified version.